In 2021, Neo Advertising successfully competed for out-of-home advertising at public transportation stops in Zurich. This talk highlights two essential parts of this project where they used cross-company data to enable offline user targeting based on online behavior. First, they will show us how they match content user consumption, I believe, to AIB segments and interest. This technical part includes natural language processing techniques for labeling and extraction of interest from data collected by TX Group-owned companies. Later, we will see they will showcase us how they transform these insights into a unique and innovative product for targeting digital out-of-home advertising in Switzerland. Milena Djordjevic and Dominic Herzog will present this to us. Welcome.
Thank you. So thank you all for joining today. I'm really happy to be here, and let's start right in. So today I'm going to talk about, together with my colleague Dominic, and we're going to tell you how we are trying to understand and reach our users in TX. So according to Arbitron study, over 70% of people notice billboard messages enough to remember them. So that means that a lot of us, whether we do it consciously or not, voluntarily or not, notice a lot of messages around us. And it's a rare occasion that we actually can make use of this information or that it sparks some kind of curiosity. And that's because in most of the cases it's quite general and doesn't really resonate with us. And wouldn't it be kind of more valuable if these kind of ads would actually bring some kind of meaning to us? And we all know that we have some kind of latent interests in our minds. So whether it's tracking topics about sports or just tracking some news about finance and market, or just relying on some latest developments in science and health, we all do have some kind of interests in our minds. So why then we don't show these interests around us? Why then we don't bring these messages around us when we're commuting, when we're strolling to the city, or just commuting in our daily lives? So today I'm going to try and explain at least one way how we can do this, and Dominic will tell our use case about it.
Thank you. Well, so today we will have the following parts of our talk. So first of all, we want to quickly give you some introduction about what TX Group is and what is the unique position within Switzerland making all of this possible. Then, as already told, Milena will talk about how to reveal user interest from consumed content. I will then show how we can map these insights to offline locations, going then forward to this use case of near advertisement and digital out-of-home targeting, and in the end, looking at some takeaways of this talk. So TX Group is actually the largest news company within media company within Switzerland and has four main pillars. First of all, we have Tamedia, which is all about paid media, having newspapers which are available all across Switzerland. Then we have 20 Minutes, which is a commuter media, also within Switzerland, which has printed newspapers as well as an online news platform which is heavily used and has a huge reach within the country. Third, we have Goldbach, which is an advertising company which allows us to advertise the ad space on those different brands within the portfolio with internal content. And finally, we have TX Markets, which are providing services about classifieds and marketplaces within Switzerland. With this portfolio, we can reach 80% of the Swiss population each month, which are consuming at least one of our services. While we're having our focus, of course, in Switzerland, we are also having offices around Europe, and one of them is here in Belgrade, represented by TX Services.
So our main idea was that these latent interests that every one of us has is actually something that we can derive from the media that we're consuming. And since we have an opportunity to offer our users media, we wanted to see how the content that this media contains actually resonates with users' needs. And if we want to understand user behavior, we need to take a look at the two major categories. One is content, and another is user-related data. And each one of them have their own set of attributes describing them. First one is actually talking about what the texts or news articles are, which sections they belong to or tags related to them. And the other one is talking about which information users want to share with us, how they develop their socio-demographic profiles, and what their behavior means. And we have them each and separate, but they're really not that separate because we know that there is an innate causal relationship between them driven by user preferences. So if we want to describe them in some similar terms, if we want to understand the user behavior, we need some common ground. But for that, we encountered a gap. So we were asking ourselves, how can we actually bridge the gap between the description of content and users? And if we want to bridge a gap or build a bridge, we would actually need materials, technology, and know-how. And for us, that would mean some domain-specific data, technology to process it on, like NLP, and the know-how or just understanding of the context of the task that we are solving, and also the responsibility that that task is carrying. And if we take a look at materials, when we started just researching how can we get these materials, we were actually looking at our task, and that was to represent content with consumer segments. And here the focus is on consumer segments. Luckily for us, there's a really neat solution in form of IAB interest, and this is a unified approach to connect content to some consumer segments which can be actually attributed to users. And the third step then for us was to form some kind of a training set. So that would be a minimal required unit to actually connect these very distant IAB interests to the content that we have. And we didn't have this at the beginning, and that's, I guess, a phobia of every data scientist not having a training set. So we had two ways to tackle this problem. And one was to do it manually, and the other was to do it automatically. So if we wanted to do it manually, in a rough estimation, it would take around 1,500 hours of expert time, so that's a medium-sized training set. And that would actually mean employing experts doing really labeling tedious tasks for over 2 months. And I don't think that sparks joy in anyone's mind. So we decided to actually take a look at the automatic route. And before even taking a look at this, and that's not something that's really widespread in industry because still a lot of people are doing some kind of manual labeling, we wanted to actually take a look what research has to offer to us. And thanks to NLP and data science being buzzwords, it's actually possible to use some of the milestones achieved so far. So one of these milestones was actually zero-shot learning. And for some of you who are not introduced to this, this is a paradigm in machine learning which states that if you want to teach a model to do some kind of a task, you don't need to have a training set, so you don't have to teach it to do it. You just need to change the initial task of the model. And that for us would mean that we would need some kind of a zero-shot model, specific kind of model, and just change the task without adding any kind of label data, which would work for us. But why this actually works? This works because the nature of these models is that kind that it can retain knowledge in much higher degree. So once it is trained on billions of parameters and billions of examples, it can actually make much more sense of that and transfer the initial task to some other task. For example, if we have a regular classification model taught to do some kind of classification on text in M classes, and we want our new N classes, we would only need to ask the model, is my text, which this model hasn't seen before, related to my class, which also the model hasn't seen before? And the model will just output yes or no. And this actually really works. So we were over the top when we found that this is actually possible. But nothing comes without a downside, unfortunately, because we wanted to use this, but we couldn't use it off shelf. We could try it out, but when we wanted to scale it, it was just impossible. And this was a pretty disheartening moment, and a lot of research was done into and put into this, but at the end, what we found out that even though we cannot build real-time applications because of the really slowness of this whole cumbersome models, we could build some training set. So that's exactly what we did. We put our content through the zero-shot model and got our training set. Not that easy, but we actually put our content through the zero-shot model, done a lot of optimization, puts a bit of Kubernetes magic on top of it, and then at the end got our training set. So what this actually meant for us, we were at some milestone for the next chapter. So now we had our training set and we could build our own model. But using this kind of transformers architecture that's actually behind these kind of zero-shot models taught us that this cumbersome model is actually quite powerful. So why not try to build our own transformer? Why just going traditional way? Let's at least compare the two. So we wanted to try it out within the framework, which is called transfer learning. And that meant that we can leverage this kind of stack, so use in some way knowledge that these models have, and add on top of it some kind of a customization components. And why this is important? Because this kind of a customization would allow us not only to adjust to our needs, to our users, but also to adjust to language itself, because we were actually doing this on a Swiss German language and not just plain German. So what we did in a nutshell, we put into parts BERT, and then we added on top of it several layers of neural networks. Of course, we needed to do a lot of testing to see which kind of combination of it actually works. And then at the end, we were able to get some kind of a stack which would allow us to get IAB segments at the end as labels. And the good thing about this is that we actually didn't need to have a lot of training data, because we were leveraging the knowledge that BERT had, and we were just adding some kind of creative component on it. So that really worked for us, because the whole process of getting the training data is not something that is as straightforward and easy. So to just have some kind of results in mind, this kind of stack allowed us to really increase our accuracy, especially compared to some traditional approaches, for example, like logistic regression, which is often used for these cases, and that was over 20%. So because of that, we were also able to increase our inference time, and for real-time application, that was a really key metric, so it was over 2 times faster. And at the end, if we take a look at the whole process, we were able to almost fully automatize the steps from getting to content, which was completely not connected to our to those IAB segments, and then put this into one almost unified approach. And how actually the results look like. So these are just a couple of articles from our platforms, and the output that model has outputted. So I won't go through every example. Of course, we can go in the questions section, but I will just maybe highlight the third one, which talks about Facebook developments and some troubles. It is marked as technology and computing, and if we take a look at the details of this article, we can see that in the text, which is in German, but I will explain. In the text we can see colored in green some keywords that the model recognized. So those are the words that actually made most sense to the model to output that kind of a category. And we see words like Facebook, online networks, technology, and these all relate to technology and computing. But we also have word company, which indicates that besides technology and computing, we also have some other latent topic. And because we had an opportunity for this model to give an output, not only the most dominant category, but also to rank the categories by their importance, by their score, we found that the second most important one was actually business and finance. So word company actually makes sense. And colored in yellow, we can see the sentences that carry the most meaning for this text. The first sentence actually just explains the title and is quite related to technology, so that made sense. But we see that further in text, somewhere in the middle, we have two second and third most important sentences, and they are not really that much just talking about technology. they talk about business aspects of Facebook's decisions. So that meant that this kind of output resonated the real life meaning of this text. And to just get back to one of the first slides that we had on one side content. We described it in some terms, and now we can describe it in consumer segments terms. That means that when we connect user to content, we don't have a gap. We can now draw a direct linkage between those two and be able to say with much higher certainty that some user is interested in some topic. So this is quite useful when you want to build an audience, for example. An audience can be a mixture of socio-demographic profile of user, platforms that it is reading, which is important for us, and also interests that they have. And this would allow us to have insight into who our users are, but more importantly, who the groups of our users are, and how we can improve their experience of our services.
Well, so as Milena has now shown, we do know interests of users, but kind of only in an online environment. Now we would actually like to map them to offline locations, which would be needed for digital out-of-home targeting. So key factor what we need here is geolocation data of the user. And we are lucky in our group that we have an awesome community on 20 Minutes, which are sharing their geolocation data with us, giving us their consent that we can use it to map it also with other data points within the portfolio and also use it for advertising purposes. Okay, second very important point is that we are now able to getting an identity graph or like a holistic view on the user. As you have seen in the beginning, the portfolio of TX Group contains a lot of different brands, and all of them are kind of operated in isolation, so all of them are getting data points of the user. So maybe one brand is getting from registration data some socio-demographic data of the users, from others we're getting the geolocation data, and from newspapers and 20 Minutes as well, we do get the user interests based on what they have actually read. Now we need to bring this together. We can do this based on hashed email addresses, or if the users are having different services on the same mobile device, which allows us to connect those kinds of data points and bring them together. So what we have now is we have those transactory data. We do have user interests through our data platform, and we are able to map them in this kind of way through offline locations because we know where users are and which kind of interest they have. And this is kind of far beyond what commercial products are offering on the market for digital out-of-home targeting, which are still on kind of very basic socio-demographic data for specific locations, which are not changing over time or to any other dimensions. So let's have a quick look at a specific spot, a specific location, and see kind of what kind of users are passing by there and what we can learn from that. So our location is in Zurich, and it's a tram stop near the ETH or near the University Hospital. And it's kind of this green circle you can see in the middle of the map. So we're looking at all users who pass at least once during the day this location and have a check on where they actually are within the city. Because this already gives us some indication whether we see different kinds of user groups passing by this location, which might also then be targeted differently. I'll show you a quick animation. So kind of each screen is kind of 1 hour during the day, and we can see where we have the hotspots of users in the city and maybe also getting kind of their intent, why they have actually passed by the station. So we start like it's midnight, it's 2 o'clock in the morning. You see like in the middle of the map there pops up some red dots, which is all around the hospital, which is of course operating 24 hours a day. When we are continuing, we can see that during the morning hours, some specific locations are popping up, or lines. I'm quickly stopping here, so it's kind of 6 o'clock in the morning, and you can see that where we see those hotspots of users, those are actually public transportation lines. So the the information, or they are using our services to consume the latest news, and we can see how they're actually traveling through the city. When we are getting a little bit further, it's getting kind of day, it's getting lunchtime, and we see a lot of activities. Let's quickly stop again. Around the university itself, during lunchtime, especially at the restaurant. And if you're moving onwards, we can then see during late afternoon, again, it pops up some red dots at the train station on the left-hand side, so those users are commuting back home. So this also already gives us that there are different kinds of users or intents of the users which are moving across this station, and so therefore also they might have different kind of interests available at those stations at different point in time. So let's stick at the station and have a look at how the interest groups are actually changing over daytime. You can see on the x-axis we have the hour of the day, while the y-axis is the share of users who are actually in one of those customer groups. If you're looking at the blue line, that's interest for innovation. And we can see that during the night, only about like 30% of the users who are passing by the station are interested in innovation, but then it kind of peaks during morning hours, nearly at 40%, and it declines a little bit during the day. We could do the same also not only with interest, but also with social demographic data. So if you're looking at the gray line here, those are users where we have a predicted age of over 45 years. And, well, maybe not the biggest surprise, but like during night hours, this customer group is underrepresented at this station, while during the day, they are getting a share up to 45%. We can switch and not only looking at this dimension, but also look at it over time. Do we see some changes in user interest or in user groups over time? And for this, we're switching the city. We are going to Basel, and we have selected a public transportation stop, which is really close to this soccer stadium. And we're looking at the time period, beginning of this year, like January, until end of March. The y-axis now is the number of users per user cluster, which we can see. And maybe you already see like maybe two interesting things happening in March. First of all, we see a little bit a level shift beginning of March, and then of course this huge peak on the 13th of March. So what happened back then? The first level shift was actually that the government has changed the restriction they have on COVID, and it was much easier now again to travel. And that's what we can see here. We see more people actually at the station. And then on the 13th of March, what happened is there was a soccer game actually within the stadium, but it was not public. But a lot of people went there to have a manifestation in front of the stadium, and that's exactly what we see there with that peak. And if we would dig into this cluster number 4, which is peaking especially, those are actually people which are very interested either in sports or what's happening in the local, so what we have for events in Basel, and that's what you can see here. So we can detect not only the amount of people changes at specific points and over time, but also we can detect such specific events and that user interest and the share of users with specific interests are changing. However, we might not only be interested in a specific stop, but let's look at a whole landscape and see, can we actually see different areas, different hotspots where interest groups are under or overrepresented. So we're going back to Zurich and zooming a little bit out. So what you can see in the middle, we have the center of Zurich, and then we have some agglomeration. Each point which you see here is one public transportation stop. Red means that the specific interest group is underrepresented, and blue means that they are overrepresented at this stop. So when we first look at the left chart, we see like interest in sports, and we kind of see that users which are in the inner city do not seem to be that interested in sports, but if you're going to the agglomeration, we see more hotspots where we have users and very interested in that topic. We see a totally different picture if we're going to food and cooking, where it's not inner city against agglomeration. we do see, like within the inner city, some areas where a lot of people are interested in that topic, while in other areas really close by they aren't. And that's really important for this use case we have on digital out-of-home targeting, because it might make quite a difference if you put your ad in one street or like 200-300 meters in another street. You have a totally different kind of audience. We can do the same with sustainability, and we can also use, again, social demographics. So on the right-hand side, you can see the predicted gender, if it's female, and you can see also here within the inner city, there are areas where this user group is overrepresented, while just nearby, we have spots where they are underrepresented. So this is kind of our use case which we had, this digital out-of-home project with near advertisement. They're also part of the TX group, so nothing here leaves our group. So we have the transactory data, we have the user interest, and we do have a brand which is especially interested in this data because they are the specialists in out-of-home advertisement. Well, if maybe this whole topic also with geolocation data gives you some strange feeling, I want to quickly address this one. So it might sound like your big brother is watching you, so don't touch it. And we need to go to have user interest. We need to go on the individual level, of course. Geolocation data is on an individual level. However, this kind of data is very restrictive in our team, which has access to it. And all the products we are building, also the ones for near advertisement, is afterwards aggregating these data. So we do not share, not even within our group, data where you could, in the end, target an individual or something like that. It's all about aggregated user interest, aggregated user groups, which can kind of be targeted. So with this project, it was part of an application from Neo Advertisement. They handed in for a tender to serve ads at public transportation stops within Zurich. And out of nothing, they won nearly all lots of this tender, which was a huge success over all well-known competitors. And even though we started this project like in March this year, this new targeting options has now been presented to the market, and they will be kind of available in January 2022, such that customers can actually book locations where specific interest groups are overrepresented, which are interested for them. So let's quickly wrap up what we have talked about today. Milena has shown how we can identify behavior, user interest in the online world, and I've shown afterwards that we can transform them actually to offline insights. This is all possible with this unique position of the TX group, where we are allowed, and we have the user content as well, to connect those different data streams across brands and create such a product, which in the end surprised the market also by pushing the boundaries and going far beyond of what they currently had to decide where they want to display ads and where not. So we would have now time for some questions. Afterwards, we're also available for discussions as well, and thanks a lot for your attention.
Okay, do we have? We owe plenty. Let's start on this, and let's be quick because we have a couple of minutes.
Thank you. Bojan from Umlaut Company. My first question, how did you respond to the challenge of geolocation information collection, which with the latest version of Android operating system? Because Google imposed like more strict, let's say, rules for collecting the location information. And the second one is, do you collect the data only from your own application, or you have like SDK integrated into other publishers?
Okay. So maybe the second one first. So we are only collecting the data from our own apps, which especially here is like the 20 Minutes app, where we have this kind of community who's willing to share with us this kind of data. I'm not fully sure about how the technically, what has changed also like with the newest version on Android. So far we do not have yet those kind of problems as long as the user really giving their consent to share with us their geolocation data. So we haven't faced any issues yet, maybe they will come.
So far you didn't notice any drop of the data that you collect?
No.
In 2021. Okay, thanks.
We have two more, one here and yeah.
Hi again. Hot topic on the privacy thing. So do you collect geolocation data only while the apps are active? Because you seem to have it for 24 hours activity. It's amazing, really.
Yes, we collect them when the users are online. However, as like it's a news platform, this 20 minutes, which gives like news whenever something happens, users are using them quite a lot, and during the whole day also, before they're going to sleep, they're checking the latest news. So it's really that they are
so
very
it's sampling
engaged.
the whole day, basically, by small sessions, right?
Yes, and also like the data points you have seen there, of course, that was like a collection over several months, so it was not just this one day.
Okay, thank you.
And here in the front row.
Hi, yes. My first is about the research with classification and training data. Is there a paper published regarding this work?
Yes, it's a zero-shot learning paper. I can send you the link.
Cool. And a follow-up, kind of what was previously asked. Now, I've worked with mobility data with like Cubic and SafeGraph, but really impressed with what you all have here. And again, is this stored on like an hourly basis, the state mobility data, or is it constantly stored? Because the problems that we were running with is the quantity of mobility data. Not only do you have it on the individual user level, but what is the granularity that you're able to access? And what percentage was that 80% of the users of the app share this information of their geolocation?
Okay, try to be quick, otherwise we can also discuss it later on. So the 80% was on all services within the TX portfolio. 80% of the Swiss population using one of the services. It's not that that many people are sharing their location data. And sorry, the first one?
The granularity of the mobility regarding time.
Yes, so the app is streaming actually the data into our data pipeline, and we have them nearly real time available.
Okay, great, thank you.
Okay, just really quick, is it easily applicable elsewhere, your model, outside of Zurich, or it would take some time to apply it?
And for us, like we have data like within Switzerland, where we have all our customers, but there we are not restricted, so we can also apply it to other cities within Switzerland. I think it's all about having those different data points available within one group and not needing to share it somewhere outside.
Okay, thank you a lot. Let me just give you let me just not mess with the names. Yes, thank you, and thank you for this presentation.
Thanks a lot for having us.